The first phone call I was on with my boss and the other directors under him, our first staff meeting, when he turned to me, it was my turn to speak. The question was, okay, Brian, so what's your plan for Complex 40 kind of thing? How are you going to build that pad? So, my thoughts were tasks that have to be done. I'm going to figure out, the manpower required, how long it'll take, the money. I'll have budgetary numbers for you in a couple of days. We confirm those up. I noticed I could pick up on the other end of the phone that some people were laughing.
Hola, soy Alejandro Sauquillo y estoy aquí hoy con Brian Mosdell. Brian Mosdell was the director of Florida operations during 2008 and 2014. Now he's the CEO of Freeboard Enterprise, that he provides space launch engineers and operation support services necessary to meet the demands of the emerging private space flight industry. And lately, when I have been interviewing Brian, I have discovered that before joining SpaceX, he was the chief launch officer of Boeing, United Launch Alliances, with more than 50 launches. Wow, it's a pleasure to have you in my channel, Brian.
Oh, thanks for having me, Alejandro. It's my pleasure. Actually, my title with United Launch Alliance was Chief Launch Conductor.
Thank you for the correction. Chief Launch Conductor.
Yeah.
I wanted to ask you about that because in 2008, you moved from an established aerospace contractor with many years of experience to a new startup with less than 6 years of experience. And how was that from the beginning? Like, how was the interview? How was your feelings when you started?
Well, it was interesting. I had a great position with United Launch Alliance. The Delta and Atlas programs had just merged, so we were putting together a new organization to conduct flight and launch operations, which I was the head of. But I had a former coworker of mine who kept calling me to come interview and talk to SpaceX. And I turned them down a number of times. And then after about the fourth request, I decided, all right, well, I'll take a trip out to California from Florida, see what this is all about, because up until that time, we all had the impression that SpaceX was like a PowerPoint rocket. It was a concept, it was an idea, and getting from concept to operations to the successes that SpaceX has achieved is really difficult to do. And incredible to achieve that. So I flew out to Los Angeles to interview with the team at SpaceX at Hawthorne, and at the time, Falcon 1 was flying. They had not been successful yet. The large rocket, which was going to launch from Cape Canaveral, at the time was the Falcon 5, which, as we know, never flew. The company went directly to Falcon 9. So I went out to interview with the team, and one of the very first things that I did was tour the production facility in El Segundo with Chris Thompson. And I was immediately impressed with the amount of flight hardware and some of the machinery and equipment being used in the factory, the stir friction welding that Chris and his team were employing on tank barrels and other aspects of the rocket hardware production. And it became immediately clear to me that this was no real, and the something, it just really caught me by surprise. I was not prepared to be impressed to the degree that I was. So as I continued through the interview process, I guess the most memorable part of that, beyond the flight hardware, was my interview with Elon. And I know in your book you touch on quite a bit, his philosophy on hiring and breaking from tradition and things like that. But and also, you point out that he asks a lot of questions, and with the real intent of learning and trying to figure out puzzle pieces on how to best proceed, right?
Yeah.
So when I met with Elon, it was no different. He asked me a lot of questions about the Delta IV, the RS-68 engines, why helium was being used, as a purge gas inside the engines and the turbo pumps, and what the pros and cons of were that and of for that, and why we didn't use nitrogen and things like that. So we had quite an in-depth discussion about the RS-68 engines and the Delta IV. And from there, it really got more involved into talking about the Delta IV program, EELV, how the government operates, that contract at the time with, the Delta and Atlas programs. And, one of the things as we got to talking and he was asking me questions is he started asking me questions that touched on some frustrations of mine, things that were very inefficient, take too long, didn't make sense, on how a program would solve problems. And the example I think that we talked about at length was on the Delta IV, on DSP 23, I believe. We had a loading test. It was the Delta IV Heavy rocket, and we were flowing very high flow rates to the booster tanks, and our liquid oxygen umbilicals inside the launch table, which is a structure underneath the rocket, they developed leaks. And in the end, it turned out the leakage was caused by a phenomenon known as flow-induced vibration, and it nearly caused a catastrophic failure on the pad and could have destroyed the rocket and the launch pad. Fortunately, it didn't. But that was something that the team at ULA then obviously had to recover from. And the path forward, or how that kind of unfolded, I guess I would say, was we would have a daily meeting, for an hour or so with technical experts, who would argue and second guess and debate the principles of the design of these corrugated flex hoses, and analytical techniques to solve the problem. And within the company, that's one layer of technical expertise being applied to the solution. But in that government program, you had the Air Force, it's their program. So the Air Force personnel are overseeing everything. They have their own contractor, the Aerospace Corporation, who's sitting in on everything. And these meetings, like I said, would go just about every day, last an hour minimum, and there'd be 40 people participating, shooting down plans, second guessing things. It was very, very difficult to get consensus on a path forward to move quickly. In the end, I think it probably took that program 6 months to settle on a redesign, build and test, and become operational again. And in the interview, Elon I think he picked up on that frustration, and I think he recognizes opportunity to tap into people's motivations to do things differently, more direct, more efficiently, which was definitely kind of my mindset at the time. The entire redesign of those umbilicals, as I said, it took 6 months or so. And, this is something that at SpaceX would have been figured out, redesigned, fabricated, tested, and become operational in about a month, not 6 months, with the engineering time and the programmatics being the big difference between the two. A couple of weeks to build an umbilical and test it. It's going to be the same for everything, but the engineering and the management style was an order of magnitude higher than what I felt it needed to be, and what I later then saw, at SpaceX, working there for six or so years.
6 years. And okay, so you spoke with Elon Musk, as you've explained, he tapped in your pain, or one of the pains that you had, that it was this bureaucracy and going really slowly, due also to the kind of contractors that you had that they were overseeing. And how was, you were convinced, you entered SpaceX? Do you remember how was your first day in a SpaceX?
Yeah, well, so to continue, just to finish out that part, we had, I don't know, a 20 or 30-minute technical discussion. It was a really fun conversation, getting into all the details of the program and the Delta IV, rockets and things like that. And when we were done, he just said, "Okay, thanks," and he just turned and went back to his desk, kind of thing. And so I didn't really know, okay, what his thoughts were coming away. But I finished the interview, and I flew home the next day, I guess. And as I was getting off the plane, there was a phone call on my cell from my future SpaceX boss, Tim Buzza, who was the vice president of launch and test. And, he's called me back, so I called him back, and he said, he thought everything went really well, but before he went any further in the conversation, he needed to know if I was really serious about joining SpaceX. So, excuse me. Like I said, I went out there. I didn't really think it would be anything more than a 24-hour trip to Los Angeles. But by the time I got home, I thought, wow, this is real. This is exciting. This is something I want to do. So, I communicated that to Tim, and he basically said, well, to back up, just to make it clear, I went out and interviewed for the job of chief engineer for the launch site. So I was interviewing for chief engineer. And when I had the phone call after the interview, they asked me, "Hey, things are not going the way we want in Florida. We have a director there, but we're not happy with him right now. Do you think you could do the chief engineer role and the director role?"
Okay.
So I said, yes, I can. So I agreed to that. And my SpaceX journey started there.
And I was thinking to ask you later, but as you pointed out that they gave you two roles, did they also give you stock options like in, I guess, like most of if not all, space Musk employees?
Oh, yes. Yeah.
And that
Yeah.
was different from your experience in ULA?
Oh, yes, absolutely. So compensation, at a company like ULA, is basically salary plus a 401k.
Okay.
That was really it. There was no stock options or any other, equity type incentives.
And the SpaceX options, they were, as far as I know, vesting at the 5th year.
Yes, that's correct.
Because Tesla, I think, is 4 years, and the rest of mass companies are usually 4 years, but the SpaceX is 5 years, right?
Yep, that's what I recall.
Okay, so going back to now you are hired with a double role, and you start, I guess, in Florida, or I don't know. How was your first day? I mean, did you start directly in the launch site in Florida because you started with the or you were your whole story in the launch complex 40, right, from the Titan rocket?
That's right. So when I started with SpaceX, the company had a right of entry to the launch pad, and that was basically to decommission and do some minor demolition on the pad configuration from its Titan configuration. So we didn't have a facility out there, offices. We occupied a building outside of the South Gate, and there were 10 of us, a 10th person here at the Cape. And I knew three of the people there when I started. But with regard to how was it to start, from a management perspective, it was interesting. I'm about traditional methods of management and establishing plans and budgets and things like that. One of my, I think the first phone call I was on with my boss and the other directors under him, our first staff meeting, when he turned to me, it was my turn to speak. The question was, "Okay, Brian, so what's your plan for Complex 40 kind of thing? How are you going to build that pad?" So, my thoughts were, I'm going tasks that have to be done. I'm going to figure out, the manpower required, how long it'll take, the money. I'll have budgetary numbers for you in a couple of days. We confirm those up. My plan was to lay out schedules and budgets and manpower and things like that, and to focus on developing, the budget estimates needed to build the pad and, the capital expenditures and the time phasing of that and things. And as I was speaking to the team at my boss's staff meeting and, offering that I would, provide budget estimates, to review and either get approval for or, go back and make revisions to, I noticed I could pick up on the other end of the phone that some people were laughing. So I thought, well, they're laughing at me. This is not, I must be really stupid here. Yeah, I don't know what's going on. So they interrupted and they said, "Hey, sorry, we're just laughing because we don't have budgets here. There's no such thing. Elon has in his head an idea of what it should cost to build a launch pad. Your job is to go build it for as cheaply as you can and still make a quality launch pad for the program." So that was probably my first big exposure to the differences between working for an established heritage aerospace company versus a new startup led by Elon.
This interview is just a small part of the research that I have made for my book, The Musk Way. After 2.5 years of blood, tears, and sweat, and after interviewing former Tesla, SpaceX, Neuralink, and PayPal employees, I have come up with a framework that Elon Musk repeats over and over in all his companies. So let me ask you just one quick question. Do you feel that your career has reached your full potential? If your answer is not a clear and confident yes, the Musk Way is for you. And actually, while editing this interview, Brian finished reading the final version of The Mask Way and told me, The Mask Way is unlike any other mask book I've read. It doesn't just recount the event, it distills the essence of Elon's playbook, the culture, mindset, and tactics that made his company thrive. Coming from someone interviewed by Walter Isaacson for his Elon Musk biography and featured in books like Eric Berger's Re-Entry and Christian Davenport's The Space Barons, that's not bad at all. Back to the interview.
And obviously you accomplished, because I read that you were able to build the Complex 40 for less than 1/10 of what it costed to build the Complex 37 of Delta.
That's right.
There are many stories that I've read in Space Barons and also in Walter Isaacson biography when you explain like the nitrogen tank, the cranes, I think the flame duct. Which was your favorite scrappiness that you were more proud or more shocked of?
I think the liquid oxygen tank, just to summarize what we did, we had an obvious need for liquid oxygen storage at the pad, and cryogenic spheres are very, very expensive. So having just come from Delta 4, where we built an 850,000 gallon liquid hydrogen sphere and a 250,000 gallon liquid oxygen sphere, I knew that the LOX sphere, 250,000 gallon size, at the time in 1999 or 2000, cost about $2.2 million. When we were at the early stages of building Complex 37, I saw a decommissioned liquid nitrogen tank sitting on the corner of the road, just doing nothing, had no piping plumbed to it or anything like that. And I went by with a couple of the other engineers, and we looked at it, and it seemed like it was in pretty good shape and could be restored. And when I went back to the Delta 4 management team and offered that up, I was basically just laughed out of the room. There's no way we're doing that. We're gonna build this launch pad brand new, and everything's going to be pristine, kind of thing. So it's probably my favorite, because the opportunity to utilize that tank was brought to ULA by myself and rejected before the SpaceX team was able to acquire it for the cost of scrap, which I think was like $86,000 when we acquired it. And then the whole operation involved with moving the tank from Complex 37 to Complex 40. It was just an awesome sight to see this giant liquid oxygen tank being moved down the road, on low transporters, and the final stretch to the pad. We basically came down a road that was really a fire break. So if you're ever at the Cape, there's a lot of vegetation and a lot of undergrowth and trees. So there's, fire roads, fire breaks. There's, other pathways cut through the trees to provide camera views to launch pads and things like that. So we ended up coming down this fire break road with seeing the liquid oxygen tank, popping up over the top of the trees. So yeah, we ended up getting that in place, and we worked to restore the tank and recertify it for liquid oxygen use. And we did something there that nobody had ever done before. Just the fact that, it was built for liquid nitrogen, and liquid oxygen, is much, much heavier. So, first order math, it should be only able to hold, a fraction of the liquid nitrogen volume. But when you really get into the engineering analysis of how the tank was built, it was over designed for liquid nitrogen. It was perfect for our application. And we had a functional operating liquid oxygen tank for a fraction of the cost. And that was just a example of numerous ones where we took equipment off the scrap heap. We scavenged equipment from NASA sites all across the country, test stands out in California, from Ohio. The bulk of our gaseous helium storage all came from old NASA rail cars that used to be used to shuttle high pressure helium gas back and forth from Louisiana to the Cape, for the Apollo and early shuttle program days. And these things were just sitting, not being used. And we were able to figure out ways to get things for free and renovate them for relatively, low cost.
Thank you, because I didn't recall understanding that well, like the pass from oxygen tank to nitrogen. So it's really interesting. I wanted to ask you also, like, there's this story about these cranes that, thanks to an old regulation that you pushed to change, you were able to acquire it or use it for much less of what it was supposed. But more than this example, that if you want, you can explain it. I wanted to ask you, like, how did the SpaceX confronted regulations in opposed to ULA?
Well, I think you explain very well in your book the idea of first principles. Instead of just accepting a solution, so often requirements are just solutions that previous engineers, previous programs came up with. You need to really understand what the root problem is and attempt to solve the root problem, in a different way. So, and if you really focus on the launch business and the evolution of programs here at the Cape, when you talk about safety requirements, the current regulations are embodied in a document called 91710. And when you talk about 91710, people cringe, about the stringency, of the requirements. The requirement set today is much more flexible and modern than it was, back in the early 2000s. And, the root of many of those restrictive and inflexible requirements, they come from mission assurance solutions imposed by big government programs. They'd rather spend billions of dollars and not fail than spend a fraction of that and maybe fail 1 out of 10. So the point of that really is, everybody's mission assurance parameters can be different. It's what you're willing to accept as risk for your business model. But the same really can be applied to a lot of the safety regulations of, in prior programs, there were hazardous events and safety issues where, a certain type of fitting, leaked, and certain type of fittings may leak and cause the subsystem they're supporting to not work properly, and become a safety issue. So what I'm thinking of specifically in my mind is, there's a requirement, that pipe fittings are not allowed to be used in any aerospace ground equipment designs. Well, that may just be because they had one failure that created one result that either violated, mission assurance parameter or created a safety concern. And you can solve those problems in different ways. Instead of saying, hey, you can't use this, you can't use this $3 fitting in this part of your system. You have to use a $300 fitting in your system. And by the way, there's 1,000 fittings across the pad. If you apply first principles to those examples, you can design a system that has an acceptable rate of leakage if your overall system can operate under those conditions. You can have a system, that has a lower factor of safety, than current guidelines if you only operate it when there's no people around. So instead of just saying, hey, the factor of safety for every piece of equipment has to be, 4-to-1 because there's a possibility that somebody might be standing nearby when this is in operation. That's not necessarily the case. There's other ways to solve things. And so I think the requirements, have really, I don't know. What was the original point? What was the original question you were trying to get at?
Exactly what you were explaining, that how did SpaceX face regulations, opposed to traditional contractors? And in really clear, maybe you said, okay, as Falcon 9 in 2020, they didn't have the crewed mission, or you said, okay, if there's nobody around, can we do it less safe? No, and I guess that these requirements, you send it to FAA or some other government, and they said, okay, if you do this, we can be more flexible. Was it something like this, or?
Yes, exactly. So in the case of, the launch pad design for Falcon 9, all the requirements were owned by the United States Air Force.
Yes.
And when we saw requirements that we didn't feel were value added and were very costly to implement, we fought hard to go defend our positions and get, requirements changes, get our requirements tailored or waivers put in place to be able to do things that we felt were the right way to do them, the smart way to do them, and the efficient way to do them. So just, things like, at the time, cryogenic piping welds had to be 100% radiographically inspected. Well, maybe if you're operating a system, and some of these codes, most of these codes, they come from, ASME, boiler and pressure vessel code requirements, which evolved for systems that are operating when people are working around them all the time. So we would see some of these requirements, like the radiography on the cryogenic piping, and say, well, this really doesn't make sense because nobody's around when we're operating. So why do we have to do this? So then we would say, well, it makes sense for us to do spot inspections and maybe radiograph 10% of the welds, because, if we're having a process issue and we're producing piping systems that have low quality, we want to know it, for our own benefit. So let's spot check 10%. So that's a perfect example of where we went back to the range and worked requirements changes with them to get approval to do that, with the justification, being that personnel would not be exposed.
Okay.
So like in ULA, in my experiences with ULA, that would never happen. that would have never happened. The requirement was the requirement, and you did it. And if you needed to do 10 times the amount of X-raying than what was really needed, and cost, hundreds of thousands of dollars, you just did it.
Okay, you've explained it really, really well. Thank you. And now I wanted to ask you, because in 2016, 2 years after you left SpaceX, PayScale, that is an American compensation software company, did a survey among many tech workers. And they asked about many things: early career, median pay, median age, median years of experience. And SpaceX and Tesla, they were the first SpaceX in 2 of these different metrics, and Tesla the second. Do you know which ones they were? Do you know that survey?
No, I'm not familiar with that survey. But are you getting at the fact that the workforce is so much younger at SpaceX?
It wasn't about the age. It was 2 metrics that I didn't mention. That is percentage of job meaning and percentage of high job stress. So SpaceX, according to the workers of SpaceX, they said that the percentage of job meaning was the highest of all the tech, and they compared it with, yes, apart from Tesla, with Apple, Microsoft, Meta, all like Silicon Valley companies. And also the first one in high job stress. So did you feel that when you were working in SpaceX, that there was a big meaning, but a big stress?
Oh, absolutely. Yeah. Yeah. The expectations are very high. And to successfully execute, such a project with so few people requires people to work, extraordinary amounts of hours. So, the norm for the SpaceX team, during the pad design, construction, and testing up through launch, we're talking about like 80-hour weeks. So, there's a lot of stress, put on folks just from how those time demands affect their private life, their relationships, things like that. There was also stress from the fact that, we were a startup. We were fighting against the establishment from day one. So when we started with SpaceX, in the early days of 2008 at Complex 40, the Air Force was not our friends. The people, the owners of the requirements, the owners of the established processes that were entrenched in their ways, they did not want to have to think too hard or take the time to consider allowing things to be done differently. So we were a constant thorn in the side, and sometimes, the distaste for the SpaceX program and its personnel, would show, out openly, with certain people. The change, I think, really started within the Air Force at the top down here at the Cape, with General Helms was the wing commander at the time. And she had a saying, or what was called breaking glass. The engagement with SpaceX and acceptance of our program and the ability of Air Force personnel and processes to integrate with SpaceX was breaking glass to them. And I think in her case, I know there were numerous times where she reportedly, sat with senior staff and basically stressed the need to communicate down through their ranks. Let's figure out if we can say yes, how we can say yes, not just immediately say no. But that culture change took a number of years to take hold, and it took SpaceX to become, the most successful launch company out here on the Cape for, the Space Force team and the mission partners associated to really embrace us. And as director, what I tried to do with our mission partners at the range and the wing is to approach all of these challenges and issues, as in a partnership. So, like, hey guys, we have to do things a certain way. This is just the way, our business is structured. This is how we approach things. This is how it has to happen. We believe the rationale and justifications for doing these things are sound. We are doing things in a safe way, even though it may not be conventional in your eyes. And we have a bigger stake in our own mission assurance than you do, but we need your help. And I think over time that feeling that the range and wing personnel were on our team really took hold, and everybody got on board. And by the time I left SpaceX, we were the darlings out here.
Yes, and they continue being. And apart from the stress that you've explained with the Air Force and with the different culture that you were clashing, you also explained me in an email that due to the unrealistic goals, sometimes you had to kind of cheat the system. You explained me something about the foundation for the hangars of the complex.
Yeah.
Could you explain that, please?
Yeah. So, I'll start off by rolling back into the stress question. Since SpaceX was really funded out of Elon's own pockets, we had to do things as cheaply as possible. And there was a lot of pressure to do so. And we were all working a lot of hours and, trying to, follow that approach to the best of our ability. But sometimes, we would come up across issues where, like we needed to build a foundation for our processing hangar. And in general, a foundation is made of concrete and it's got steel rebar all throughout it to handle, all of the tensile loads within the concrete. And when we put together the purchase order for the foundation construction, Elon would not approve it because he thought the cost of the rebar was too high, and he wanted us to go, figure out a better way, kind of thing. And this may be this as I look back and read into your book about first principles, this is probably a first principles opportunity, for us to say, well, if we can't afford rebar, let's figure out some new innovative structural manufacturing technique by replacing rebar with epoxy or some other type of chemical resins, in the concrete mix that do the same or better. But when you're building a launch pad, at the time we probably had 25 people out there at the launch pad, and you have to get the foundation built because the building materials are coming, a couple of weeks later, and the flight hardware is coming. Sometimes you just don't have enough time to go and really, re-engineer the wheel. So in that case, in particular, we just couldn't figure out a way around. We thought the design was as efficient as it could be. Our engineering team had gone back and obtained source pricing from all types of suppliers, including China, and other, foreign suppliers and things like that. And in the end, what we did is we just restructured the purchase order package to remove the rebar and then break the rebar up into separate, smaller purchase order packages that were below Elon's threshold of approval so that we could get it through.
That was also thinking by first principles to make things done. But yeah. I don't know if you have got to the end of the book, because in the last chapter is the Musk wave replicable. I studied the Asperger of Elon Musk, so I interviewed Temple Grandage, that she's worldwide known autist, and she has many books about autism, and also another teacher. And one of the traits of people with Asperger, that is autism type 1, is that they say whatever they think, and due to the fact that the prefrontal cortex, they have a different kind of wiring, they don't realize of the consequences, how people are going to feel. So you told me also in the email that Elon Musk said something about how he knew better the Falcon 9 than all SpaceX combined. Would you explain that? Because I'm curious about that.
Oh, yeah. Well, in the early days, Elon was doing all sorts of interviews and, GQ and all sorts of things. And, in one of the interviews, he made the comment that he knew more about the Falcon 9 than every person in the company combined. And so, we all thought it was ridiculous. Some people were, offended by it and, were consumed with, the ego of saying such a thing, kind of thing. But, I'm sure that, I'm sure he knew as much or probably more than any individual in the company. But some people definitely took that, as a slap in the face, as a completely egotistical statement and a dismissal of the talent that was working for the company and building the program for him.
Thank you for that clarification, and it makes a lot of sense. There's like many mantras, many principles that Elon Musk repeats. I mean, you've already explained the question, every requirement that you were fighting. You also explained like the thing by first principles and not by analogy. Also, he has said something like, is right, wrong is wrong. He tends to stretch as maximum as he can both the time, the deadlines, and the budgets. Did you feel that there were some other principles, whether said or understood in SpaceX during your tenure?
I'm not really sure how to answer that. I think going back to the the stress level at times, and the fact that Elon obviously is not a traditional chain of command person. He will just pull from any resource that he needs to get an answer. I think some people, I think a lot of us felt like that type of style created like a gladiator mentality where people would be pitted against each other, to fight to the solution instead of collaborating together. So, from a stress standpoint, you always felt, not always felt, but, there was some times where you'd feel like, hey, you got to watch your back kind of thing, because somebody else is, maybe throwing you under the bus, for their own personal gain, or, um, you know, passing blame on, or, not taking responsibility for issues of their own, out of fear that, Elon was known for, firing people. So, you know, kind of thing. So I guess that's what I say is, the management style did definitely create like a gladiator mentality where it was you're fighting for your life, and an attack could come at you from any angle.
Brian, as I don't want to steal more of your time because you have been super aggressive, in all the interviews, especially when I upload to the channel, I end up with one game that is the one word game. So I just tell you one concept and you tell me just the first word that pops to your mind, but you cannot repeat, okay?
All right, I'll try.
Okay, Mr. Brian Mosdell, what is the one word that comes to your mind when I tell you complex path 40?
Complex 40?
Yes.
Falcon 9.
SpaceX scrappiness.
Nimble.
Elon Musk.
I just got flooded with like 1,000 words in my head. I don't have one. I do admiration.
Okay. Falcon 9 maiden flight.
Falcon 9 maiden flight. Exhilarating.
Meeting Obama. That is a picture of you with him.
Awesome.
SpaceX iterative approach of building products.
Unconventional.
Falcon 9, this I didn't have, but I have recalled. Falcon 9 horizontal assembling of the rocket.
Erection.
Starship.
Stainless.
And last but not least, Mr. Brian Mosdell.
Happy.
You are. Thank you very much. It's been a pleasure. If somebody watches this interview and they want to follow you or contact you, or what is the best way, or what do you recommend them?
Oh, I don't know. I'm not really active on, any social media platforms like Instagram, and, I have Facebook, but never look at it. I guess let's say if that were to happen, you let me know and I'll set something up. Because as you know, I very, very rarely even look at LinkedIn.
I know, and I have to tell you that today I really enjoyed the two interviews. The second one I couldn't finish, but I was enjoying really the two only interviews that I found of the Space Radio of 2008 and 2012 with David. I don't remember his name. And
yeah, the space show.
So much here. The first one was you were making a tour of the complex 40, and the second one was just a few months before the maiden flight of Falcon 9.
Oh, great. Yeah.
And I really enjoyed it. I will link it in the video. And
okay.
Now to wrap the interview, I have a tradition that is, I started the interview saying, hola, soy Alejandro Sauquillo y estoy aquí para que triunfes, which means, hello, I'm Alejandro Sauquillo, and I'm here for you to succeed. I want you to say the same thing, but with Brian Mosdell. So it would be, hola, soy Brian Mosdell y estoy aquí para que triunfes.
Soy Brian Mosdell, estoy aquí, what?
Para que triunfes.
Para que triunfes.
Para que triunfes is succeed. Para que triunfes.
Para que triunfes.
Great. You speak perfect Spanish. You can be.
I don't think so.